thank you all for coming. I'm really glad that you chose my session today. As was said, I'm going to be talking about how to secure APIs and microservices using OAuth and OpenID Connect. A little bit about myself. I'm an identity specialist. I've been working with OAuth and API security for 10 years. I've been working prior to OAuth with previous protocols that were used to do similar sorts of things. So I have a pretty extensive background in this area. And today what I want to talk to you about is how to apply it to the API space, which is pretty interesting. We talk a lot about this at Nordic APIs, which Curity, the company that I work for, is in charge of organizing and hosting. We have various events where we talk about microservices in all aspects, whether it's design or business models or other things of that sort, in addition to security. So if you're interested in that, a lot of the information that I'll be going through is provided in ebooks and YouTube videos and other things if you want to take it a little slower or go back and review those. So you can find a lot of that at Nordic APIs. And also for those of you who don't know, Curity is an identity software company. We provide an OAuth server and an OpenID Connect server, so we've implemented these protocols and understand in the very, very deep detail exactly how all of these work. So without any more ado, what I would like to talk about is first of all some OAuth basics so that we can understand how it works in general and then begin applying it to a use case like microservices. So if you do have questions as I go through any of this, please do jot them down. If you don't have access to the app or something, feel free to grab me afterward. We'll be at the booth out here also, so you can find me there if you do have questions, because it does often spark a lot of thoughts there. So please feel free at the end or later. On the basics, what you need to know is that OAuth is a sort of protocol of protocols. It's a meta framework or a basis on which other protocols are built, and that's really the intention. It's a predecessor of something called OAuth 1.0. No one ever uses that or talks about that anymore. And really, it's OAuth 2 or nothing. So when I'm saying OAuth, be aware that that's what I mean, is version 2. The framework itself is used by many other related standards, some of which we'll talk about today, like OpenID Connect, and using that as the sort of basis. And how you do that is the protocol will define, OAuth will define many things like can be done or should be done or may be done, whereas these other protocols will say, you know, they must be done or they have to be done, so making them mandatory in different cases. And besides OpenID Connect, examples of protocols that do that are UMA, HART, which is a sort of profile of OAuth for the health sector. And the important thing that OAuth is doing is addressing some use cases related to not sharing your password with the application that you're delegating to. So delegated access is one of the primary use cases of OAuth. The reduction of password sharing is another. And thirdly is the revocation of access. So that if I want to disallow a certain application to access my resources, I don't have to revoke all access to all applications. So in the battle days when we would give our password out to all sorts of different client applications, the only way to revoke access was to reset my password, which would revoke all access to all apps. So now using OAuth, we have a more fine-grained way of revoking access. In OAuth, there are various actors. You can see them here. So we have a resource owner. A resource owner is like a user. The standard doesn't talk about a user per se because the resource owner could also be an organization. It could be some other sort of entity, but typically it is an end user. And then there's a client, and the client is the application. And so this could be a web app, it could be a mobile app. And then there's the authorization server. This is the security token service, or the entity that is in charge of issuing tokens and figuring out who the end user is. And then there's the resource server, the one that's actually serving up that resource. So that's the API or the microservice. And the flow in general works like this, where the client application will get a token and then call an API to use the token. So the basic flow to the end user looks like this, where we request access. And that requesting access can be done in all sorts of different ways. It could be automatic, because you always need to authenticate. So if you try to come to a protected resource, it will just initiate you over and get you logged in and authorizing that application. It could be something like click here to log in, click here to start, click here to sign up, things like that. So requesting access could look different in different cases. Afterward, you'll see some sort of login screen typically. Login could be done anonymously, so this is also optional, but login will typically show some sort of interactive user dialogue, and that could collect any kind of credential that you want. Of course, there's the ubiquitous username password, but this could be other things like an MID or a bank ID or a SMS two-factor authentication. The OAuth spec itself doesn't make requirements on this, just says in certain cases that the user must be authenticated to a sufficient degree. And then the last thing that the user may see is a consent screen, and this is an interactive prompt asking the user, do you want to allow the application or the client to access resources on your behalf? And so this consent screen will sometimes be implicit and not shown. That could be the case when you consented when you signed an employment agreement or opened an account at the bank, or when you became, or when you downloaded the software, it was in the software license agreement perhaps. So consent isn't required to be shown, but very often it is when the application is provided by one company and the authorization server is provided by another company. So there's a lot of flows in OAuth and even more defined in OpenID Connect. I'm not going to go into all of them today. We have a workshop on Thursday where we'll actually delve into almost all of the flows actually. So you can have that to look forward to, but at least for this morning what we're going to talk about is a very popular flow called the code flow. And the way that this works is that the application will start by requesting the user to be authenticated and authorize that application to consume resources on behalf of that user. So the user will be redirected from the application to the OAuth server. The OAuth server will authenticate the user, like I said in that previous slide, and then after that, the consent could take place, and then what comes back to the application is a short-lived authorization code. This authorization code signifies that the end user has authenticated and has consented to the application accessing resources on behalf of that user. This authorization code is called a nonce, or a no more than once. So this short-lived authorization code can only be used one time, and it can only be used one time at the authorization server within a very short amount of time, usually about 30 seconds or so. And it takes that authorization code and sends it to the OAuth server. And it sends it to the OAuth server through a back channel communication. So the initial request is happening through the front channel in the user's browser or user agent, and then this step of the flow is happening directly from the client application to the server. And because it's back channel, we can also authenticate the client. So the client can prove who it is through different means, maybe a client ID and a secret, or maybe an X509 certificate and a key that it has access to. There's different ways of doing this, but the client is at this point able to authenticate, which is important. And if it does, then the client will be given an access token. And in the code flow, in addition to an access token, you could be given a refresh token. I'll explain what those are shortly. So once it has the access token, it can call those backend APIs and microservices. Okay, does that make sense? If not, jot down a question and we'll get to it at the end. In OAuth, actually since OAuth 2 even, there is such a thing called scope or scopes. And this creates a lot of confusion, so I want to explain what this is. And during that code flow, you can say, I want a certain scope of access. I want to have access to a certain number of resources or a realm of resources. And so those scopes are a sort of grouping of claims. And those claims can be used by the API for permissioning purposes. So it can, in the API, decide if you're allowed to call this API based on information about the end user that is obtained, and so that the application doesn't have to ask for lots and lots of scope or claims. It can ask for instead a scope, which is a grouping of those claims. Very often you'll see it presented in something like this, hopefully not so egregious, but they are reflected on the consent screen because this is what the user data is that the resource owner is releasing. And so in OAuth, there are no standardized scopes, so you can invent your own. So very often people will map the scopes into like their product or product portfolio, but there's other ways to do it as well. OpenID Connect does define a few scopes that are standard, and we'll look at some of those during the demo actually. As I mentioned, there are different kinds of tokens. We have access tokens and refresh tokens. An access token is meant to be sent to the API or the microservice. The refresh token is meant to be sent to the OAuth server. And it was sent to the OAuth server in order to extend the lifetime of access to the resources. So when the user authenticates and authorizes, that access token that's issued typically lives for a short amount of time, maybe 30 minutes, 60 minutes, and not much more than that. But you don't want to keep asking a user to log in so frequently. And so if you trust that application, if that application was able to prove its identity by authenticating, you may also give it a refresh token so that the client application can call to the OAuth server and present that and get back a new access token. And in effect then, what's happening is the refresh token is sort of like a password that you use to jumpstart a session with a website. So you don't have to ask with every HTTP request, like, prove who you are, although you can, of course, do that in basic authentication. Usually you start with a password, you get a session, and you keep using that over and over again. That's analogous to a refresh token, whereas the access token would be more like that session that you have with that web server after you've bootstrapped it. So I hope that analogy helps to understand those two. If not, then jot down a question. There are different profiles of tokens. There are bearer tokens and then what's called a holder of key tokens. To help understand this, you can think of bearer tokens like cash. Cash is a bearer bond, like the one who bears the note is the one who's able to use it. The one who gets the $10,000 bearer bond in the spy movies or the bank heist movies, they can go and spend those because they bear them, they carry them. So bearer tokens are the same sort of thing. If you have it, you can use it. So if I find some 100 Danish kroner out here on the street, I can go and buy a coffee, and the barista is not going to ask me, like, did you find this on the street? It's going to give me a coffee. Alternatively, there's something called holder of key tokens, and this profile of tokens is meant to lock down the presenter of the token to make sure that it's the same entity or the same thing to whom that token was issued. And this is analogous to more like a credit card. So if I find your credit card out on the street as I'm leaving and I go to the cafe and try to buy a coffee, the barista is going to ask me for my driver's license or ID card and know that, hey, this credit card isn't being presented by the same person to whom it was issued, so I can't give you this coffee. So we can do that same sort of thing with tokens. And the reason being that we want to have more assurance that the entity we're talking to from our APIs is really the one we think it is. There are different types of tokens. So OAuth doesn't define any certain type that must be used. We commonly hear about some of them, but the OAuth standard itself does not say any certain kind of token that must be used. So we can use legacy sort of tokens like WS Security and SAML tokens. We can also have custom ones like just a GUID, like a unique identifier, or some other homegrown kind of token format. We could also use stuff from back in the day like access managers. And that's actually quite helpful for like migration. So be aware that you can do that so that you can issue a right kind of token that might simplify a mapping to a legacy system. We can also use something called CBOR web tokens or COT, CWT, and of course we can use a JSON web token, which are very popular in the news. A JSON web token, pronounced jot, like the English word to write something down quickly, are lightweight tokens that are meant to be passed in HTTP headers and query strings. They're really meant to be used in mobile environments and constrained environments, not as constrained as you would use like a CBOR web token, but still more constrained than something where you would be using an XML parser and SAML tokens and things. The encoding being done with JSON makes them inherently more secure than XML, in my opinion, because you're not having to do things like normalization. There's no entity expansion. So not only by using JSON encoding are you more secure, but you also have a lower tech barrier. You can find JSON encoders in every programming language, whereas you wouldn't find that in alternative formats, even CBOR. But definitely XML. So they're very compact. You can. It's important to realize that you can encrypt them, you can sign them, and you can do neither. So the JOTs, if you ever work with JOTs that you've heard about, are always signed. They're always signed by some sort of private key. But you can also encrypt them, and you would encrypt them with the public key of the API, so that only that certain API could decrypt it. And you can do neither if you want to, and there are use cases for that. So they're not the only kind of tokens, I hope you got that, that you can use with OAuth. In certain cases with OpenID Connect, you have to use JOTs, but with OAuth in particular and API security, you have those options. Other options that you have are the ways that you pass tokens. So you can pass tokens by value, and you can pass them by reference. I assume that from the naming of that as programmers, you automatically get it, but let me explain. If not, so if you pass a token by value, what I mean by that is all of the identity data that represents that end user is in the token itself. So a JSON web token would be an example. I have my first name, I have my last name, I have my shoe size right there in the token. Whereas a by reference token is a handle token or an opaque GUID that refers to the actual data. So if you want to get the shoe size or the hair color or the first name, you have to dereference it just like you would in programming. You call a function, it's a pointer, you dereference that pointer, now you have access to the data. And the way to dereference it is to ask the one who has the identity data, and who is that one? That's the OAuth server. So there's actually a standard API for dereferencing tokens, and it's called introspection. I'd also like, before I get into applying this to a microservices use case, talk about the proper usages of OAuth and the improper usages. So OAuth is not an authentication protocol. It says in certain cases that the user must authenticate, but it doesn't say how, it doesn't say to what level of assurance, it doesn't say with what kind of credential, anything like that. So we can't really say it's an authentication protocol. There's no challenge and response, in exchange defined, anything like that. It's also not a federation protocol. Federation is figuring out who somebody is in one security domain and reusing the answer to that question in another domain, and none of that's defined in OAuth at all. And it's not really for authorization, which is kind of strange because it's OAuth and it's not for authentication or authorization. So what's the auth part for? It's a misnomer. OAuth is for delegation. So to help us understand the distinction, especially if English isn't your first language, and need to dig into what I mean by authorization versus delegation, because even from other OAuth experts, I get pushback on this. So let me justify that. Imagine that you are the owner of a business and that you hire an assistant to help you manage the accounts of the business. And you say to that new assistant, you can go to the bank, you can take out money from the business account and do the work of the business, so I don't have to. And you do that, and then the assistant goes down to the bank and says, okay, I'd like to withdraw 10,000 Danish kroner from the account. And the banker is going to say, sorry, disallowed. You're not able to do that because neither you nor the business owner signed the right paperwork or did the right process and procedure for me to believe that you are a legitimate assistant able to take this money out of the business account. So I, as the business owner, delegated my rights to have access to the account to the new assistant, but the new assistant wasn't authorized because the procedure wasn't followed. And so the API all the time, the microservice, it's that entity's decision to return the data or not. It's not the resource owner by simply consenting and allowing a certain application to access data that is going to finally determine if that data should be returned. If the authorization policy is very, very simple, and that is if the user says it's okay, then sure, the delegation looks very much like authorization, but they are different things. Because very often in high security environments like banks or governments or healthcare, gambling, those sorts of things, the authorization policies are very, very complicated. And so it's important to realize that not all of the things necessary to make that authorization decision need to be moved into the OAuth server. The APIs and the microservices remain in that important role. So that's, as you think about a microservice-based architecture, don't think, okay, I'm going to have to send everything to the OAuth server, because that's sort of contrary to microservices philosophy, right? Let's talk a little bit about OpenID Connect as well. OpenID Connect is used to build the web applications and the mobile applications that are going to call our microservices and APIs. So it's important to know how OAuth is extended by OpenID Connect, because what's happened with OAuth is that the client is sort of left out of the party. The app doesn't get access to any of the user information. And very often, the front end will need to know some amount of information about the end user. It will need to know maybe like at least first name to greet the user, or something of that nature. But all of the identity data is for the API, and that's in the access token. So OpenID Connect defines a standard way of sort of inviting the client application to the party by giving it its own token. And that token is what's called an ID token. So it's important as you build your microservices to not mix things up. So don't like start sending your front end's ID token to your back end microservices. No microservice should ever consume an ID token. You can write that down. It should get access to it should use an access token. The front end should be using an ID token. And an ID token defined by OpenID Connect is a JSON web token. And it's signed by the private key of the OpenID Connect provider. The OpenID Connect provider is an unfortunate additional word that we get with this specification that means an OAuth server that can do OpenID. And it's signed by the key of that OpenID Connect provider. And so this allows the client application to verify that the identity was indeed issued by that provider. In addition to the ID token, the other novelties of OpenID Connect is that it provides a user information endpoint, or user info endpoint. And this user info endpoint can be called with an access token, and the information that is returned from it is the user data that the resource owner, the user, consented to allow the application to have access to. So on that consent screen, if I see email and I see my profile data and I say no access to my profile data, the only thing that it's going to have access to when calling user info is the email, not my profile. So the consent and the delegation is related to the API's response. And this standard user API is provided by or hosted in the OAuth server, or the OpenID Connect server. The third novelty of OpenID Connect is that it defines some additional flows, and those are 4 variations of what is called the hybrid flow. These are used to create applications that have a single page front end and a back end. And the single page application can get an ID token then. It can get also an access token, and ID token, access token, or both. So depending on what the front end, like JavaScript, needs, it can get that. Plus, the back end, like the server component of it, will still be able to get an access token, a refresh token, and an ID token, which are distinct and separate from the ones that the front end gets. And the last couple novelties I listed up here are request objects and claims. And if you want to know about those, you can grab me at the booth. Okay, so let's bolt on OpenID Connect to that code flow we went through before. So here I have what's called a relying party, another unfortunate additional name that just means an OAuth client. And the application or the client will make the request like before with the code flow, but this time it will include at least one additional scope, and that scope will be OpenID, and that will be received by the OpenID Connect provider, the OAuth server. And when the OAuth server sees that scope of OpenID, it clicks itself into OpenID mode. So it's very, very often that an OpenID Connect provider is an OAuth server as well, and it can do both of those. And this is the way you tell it which of those protocols to follow. So then, once the server receives that request and the user is authenticated and has delegated its rights to the application, that authorization code will be returned again to the application, the relying party. The relying party will send that authorization code to the OpenID Connect provider, at this point authenticating on the back channel like we talked about before, and the results will be an access token and an ID token, and maybe even a refresh token. So now, inside of that ID token, it can do some additional checks on it to make sure that it's applicable to that application. And if it needs more information about the user, it can use that access token to call the user info endpoint and get that, and then the user info will be returned. Okay? So the code flow with the OpenID scope and using the extra, or using the access token to call that extra endpoint user info. So if you have questions on that, just write them down. So again, ID token is for the client. Now the client is invited to the party. So the access token remains for the API forevermore. Okay, so access token is for the microservice and the API. The ID token, it provides the client with information about the username, shoe size, hair color, things like that, but also additional metadata of who issued the ID token, expiration time. You can use this to pair sessions, for example, on the front end, and this is a good thing so that the security server is actually stipulating those sorts of things. Not required, but a good recommendation. The user info endpoint, you can use it for token issuance, you can use it for user discovery. You authenticate with the access token, like I mentioned, and its output depends on the authorized scopes. So if I authorize more, you'll get more. If I authorize less, you'll get less. All right, demo time. Excuse me. All right, so here I have an application. It's written in Python, my favorite language, but one that is hard to do security in, I feel. So I've written this application, and it's not going to do any sign-in, any login, anything like that. It's going to sort of outsource it to the OpenID Connect server. So remember I said in the slides it always starts with like a getting started or sign up or login button. So that's this blue one. So I click that, and I'm teleported over to the OpenID Connect server. Coincidentally, Curity's OAuth server, but never mind. And here, like, I'm already outside of the standard. I started the flow, and then the OAuth server said, okay, I need to figure out who the user is. And in my setup, this client is only able to log in with 3 different login methods. I actually have like 30 configured on my server, but only 3 of them can be used for this application. So as the end user, I might see something different. If I'm using a different application, I might not see anything here at all, just to give you guys an idea. So I'll select username and password. I'll log in, and now, after that login, this initial request, the authorization request using the code flow finishes up, sends it back to the Python application. The Python application uses that authorization code and calls the token endpoint on my OAuth server and gets back a few tokens. The token that it gets, firstly, is the ID token. So that's what you see here. In this particular case, you're seeing things like who the user is. We logged in as John Doe. We can see that this token has a purpose of being an ID token. We can see the authentication method, this authentication class context reference, ACR. We can see other things like this ID token was issued to a backend because we did the code flow and other things. We also see that we have an access token, and we can use that then to call APIs. And because this application logged in, my OAuth server trusted it enough to give it a refresh token. So now if I use that access token, I call the API. And a few things that are interesting about this is that I can see who the user is. I mean, we can see who the user is because we had this ID token. Our client was invited to the party. But here I have the access token. How did the API turn that into John Doe? And how did it know the level of access or the scopes associated with that token? To answer that question, we need to talk a little bit about how to make all of this work with microservices. So if you have questions on the app and the demo, write them down, and we'll come back to it at the end also to look at some more things that we can do with it if we have time. Okay, so how did that API figure out that it was John Doe? We use something called the phantom token pattern. And the phantom token pattern is a privacy-preserving architectural token usage pattern for making sure that we don't give too much information to the front ends and only enough information to the back end APIs and microservices. This is the pattern I believe that almost all of you should be following when building your microservices. If you're not following this pattern, I think you have to have a very good justification for doing it. So what is that pattern? Let's talk about the basic approach first of all. So initially we said the user is redirected to the OAuth server. User logs in, and when the user logs in, it gets that GUID access token that you saw in my Python front end, remember? And that is completely useless. It's a by reference token, so we need to dereference it. And before I said that the way to dereference a GUID or opaque access token was to call the introspection endpoint. So we need to do that because if we call the backend APIs with that, the APIs themselves won't have any user information. So they'll have to do the dereferencing. So usually what happens is there's some sort of intermediary in place in front of an API. So the API will have some sort of broker. It could be a bona fide gateway. It could be one of the microservices job to actually broker in access. It could be other things. But some sort of reverse proxy or middleware will be in place almost all the time when accessing APIs from an external network. So now we want to convert that reference token into a by value token. And the reverse proxy is in an ideal position to help us with this so that every microservice doesn't have to do it. So as we call into the reverse proxy, we can use introspection to actually switch that by reference token to a by value token. So through the introspection endpoint, we can issue a new token or change the representation to a new format, which is a by value format. So the response then to the reverse proxy is a full-blown JSON web token. And there then it can cache that for an amount of time that is specified in the HTTP response to that introspection call. And then it can forward the JSON web token. So now the microservice doesn't have to deal with the by reference token. It also doesn't have to do the conversion itself. It can just use the JOT access token, and this is provided in the HTTP authorization request header. So it's all the user data is right there, and it can begin to operate on it without having to make any outbound calls to the OAuth server or even an identity repository. And so what happens then is on the outside to the application, like my Python app, all it sees is the GUID and not any user information. whereas on the back end, it might have lots of user information, and that JSON Web Token could even be extremely huge, too big even to provide in a HTTP request header. We can use other related standards to actually serialize that JOT token in the request body. So size constraints also go away with this pattern. Okay, that's Phantom token pattern. That's how I believe that all of you guys should be integrating OAuth into your microservices in a nutshell. Benefits of the Phantom token approach: you end up with a smaller regulated space. So if you're in a regulated industry like gambling or banking or healthcare or whatnot, the front-end client application is not regulated because it doesn't have access to any PII, personally identifiable information. The ID token could include PII or not. So I don't have to include like medical record information or social security information in that ID token. And if I don't, then it's certainly not a regulated space. So that's one of the benefits of the Phantom token pattern. It's also not possible for an attacker to gain access to that identity information by like decrypting the token, because the opaque token isn't encrypted. It's just a handle to the information, where the alternative is to use a JWE, an encrypted JSON token. And if you do this, then you are putting the decryption inputs into the hands of the attacker and saying, I dare you to decrypt this. And it can happen. Maybe about a year ago now, there was a vulnerability in virtually every JSON Web Token library out there that if you encrypted using elliptical curve, it was possible to gain access to the plain text without having the private key. So the access token that is opaque is more secure inherently because it is not input into a decryption algorithm. And the JSON Web Token sent by value only requires a compromise over TLS or a compromise of the transport. And thankfully that doesn't happen as much as it did 10 years ago with things like beast attacks and stuff like that. But it does still mean that if we put the PII into a JSON Web Token and only rely on the transport, if that is compromised, then the information is available in plain text. So the other thing is that we don't want the front-end applications to gain a dependency on the access token's content. So if we issue a JSON Web Token as the access token, the front end, like my Python app, could start peering into that token and pulling out things like social security number or maybe the last name, because only got the first name in the ID token and wants to show my first name and last name, and now the API wants to remove last name, and the front end breaks. So by having different tokens for different entities in all of this, we control our dependencies, which is also one of the important parts about microservices. This pattern is standard compliant, so it uses OAuth or OpenID Connect, and then it uses introspection, and it's vendor neutral. Drawbacks: we got the network call for dereferencing the token. I would say that that's not really a big problem because we can cache the token, and the token is globally unique because it's a GUID. So we can cache that actually across all of our APIs, and we can preemptively fill that cache. So if the OAuth server actually sends a message every time it issues a token to the API gateway or the reverse proxy, it could preemptively fill that cache to avoid later cache misses. We could also, of course, use a very fast reverse proxy that could handle these things quickly. And another drawback is that it doesn't work with multi-tenant scenarios. So if we have a GUID and it's coming into an API, and if there's nothing in that API request to tell us which tenant we're operating on, we need to make sure we're calling the right introspection endpoint, and that could be for tenant 1 or tenant 2, and if there's nothing in the API request to tell us that, then we're not going to be able to distinguish that. So that is one admitted drawback, but I think there are other solutions for that we can get around without having to sacrifice the use of this pattern. Alternatives is use a JSON web token that only contains the issuer, the authorized party, expiration, some sort of identifier, and maybe the audience of the API. This would definitely help us overcome the multi-tenant scenario. This is what HART, remember one of those other protocols I said built on top of OAuth. This is what they define to be the access token in that protocol. But the thing about it is you still have to introspect it. So if the problem or the drawback here is around performance, the way to actually solve that is with the preemptive cache population and with caching in general. So summary. There are various actors in OAuth. We have the resource owner and the resource server. We have the client. We have the authorization server. We have various flows. I went through the code flow, but there are others like implicit flow and hybrid flow, and various others like revocation, which I didn't have time to go into, but at least we talked about the code flow. We saw how that works with OpenID Connect as well. We saw different kinds of tokens. Remember, they have access tokens, you have refresh tokens, and ID tokens. We looked at ways that you could pass them around using by reference and by value. And we also talked about profiles of tokens. So we have bearer tokens that are like cash, and we have holder of key tokens, which are like credit cards. And we have appropriate usages of OAuth, and it's not authentication, it's not authorization, it's certainly not federation, it's for delegation. So you need to be thinking about that. And as you apply that to a microservices scenario, I encourage you strongly to look at the phantom token pattern where you issue a by reference token and convert that as it comes into your network to a by value token so that your microservice has a very easy time operating over the identity data. I want to leave you with a little bit more information. So if you come to our booth, not only can you win a Nintendo Switch, but I can answer your questions. Or maybe more importantly, you can win a Nintendo Switch. And there's also some tutorials. If you go to curity.support, there's various explanations of all these different flows. Even those we didn't talk about today, there are a lot of code samples on github.com/curityo using different frameworks and toolkits. And we have the workshop that I mentioned on Thursday. And you can go to curity.io if you want to download our server and try some of these things out yourself. So that's all I have for now. Thank you so much for listening.